So we're jumping into 12.3b. Yes, we're skipping 12.3a. But I wanted to touch back on, there was one more example from yesterday's notes that I didn't get to. I want to start off with that example, just to give you another example of how to do that whole 2 points thing. So they're telling me, again, this is the last problem on the 12.2b notes. So I'm just going to do it on the back side of the notes you were just given. So they're telling me that a of 3 equals 10. In other words, I have a point what? 3, 10. And I have another point that's what? 6, 270. And they want me to write the explicit formula of the geometric sequence. And I've been given 2 points. Okay? Everybody with me? So, here's my 2 points. My explicit form would be f of x equals the first term, which we call f of 1. Now, this is not f times 1. Remember, this is a notation that just means the first term. You may scroll in a little bit. Is that better? Times what? R to the x minus 1. You with me? So if I plug this point into this equation, what am I plugging in for f of x? 10, because f of x means y, correct? So I have 10 equals the first term, I still don't know what it is, times, I don't know what my r value is, but I do know that if y is 10, x is 3 minus 1. So that simplifies to what? 10 equals f of 1 times r squared. So far, so good? I'm going to do the same thing with this point. So what am I going to plug in for f of x? 270 equals f of 1 times r to the what? 6 minus 1. So that simplifies to 270 equals f of 1 times r to the 5th. Are you okay with me up to there? Okay. Now I need to take these two equations that I just simplified, and I need to write them one on top of the other, but which one goes on top? The bigger exponent. It'll still work if you put the other one on top. You're just going to be dealing with negative exponents, and that means fractions, and it just gets messy. So I'm going to leave this one on top, and I'm going to write the other one directly underneath it. And what am I going to do? Divide. So what's 270 divided by 10? 27. What happens to f of 1 over f of 1? And r to the 5th over r to the 2nd equals r to the 3rd, right? For those of you that are not quite understanding that, this is what r to the 5th looks like. That's what r squared looks like. Cancel, cancel. You're left with r to the 3rd on top. So if 27 equals r to the 3rd, I take the cube root to get r. And what does r equal? 3. Cube root of 27 is 3. So I have r. This, I think, is where your question came up. Where do you find f of 1 now? Well, you take that r, and you're going to plug it right up there. So 10 equals f of 1, because I still don't know what f of 1 is, times r squared. Well, I'm going to call that 3 squared, because I know what r is now. What is 3 squared? 9. So I have 10 equals f of 1 times 9. How do I get f of 1 by itself? Divide by 9. So f of 1 equals, 10 doesn't divide by 9 nicely, so we're just going to call it 10/9. So if I have my r value and my f of 1, my final formula would be f of x equals 10/9 times 3 to the x minus 1. Any questions about that? Was that helpful to see that again? Okay. Yes.
it matter when you plug in which one you plug it into?
Does it matter, meaning does it matter once you get this, whether you plug it into this equation or this equation? It does not matter. Usually you're going to want to plug it in here just because it's the one with the smaller exponent, so it makes numbers more reasonable. But it doesn't matter. You'll get the same value for f of 1. Okay? Any other questions before I move on? Okay. Turning it over and officially getting into 12.3b. Recursive rules. We saw that when we did our project, right? There were explicit rules and there were recursive rules. And what did I tell you about the recursive rules? Skip them. Didn't I say skip them? Because we'd get to it later. Well, now is later. Here we get to them. So, I have a sequence here. This is actually a very, very famous sequence. So famous that it has a specific name. I'm not going to tell you that name. But my question is, can you tell me what the next term is? 21. Okay. How did you get that?
You add the last two numbers together.
Oh. So you're saying if I add 8 and 13, that gives me 21. Was that the same case earlier in the sequence? So for example, 1 plus 1, does that equal 2? Does 1 plus 2 equal 3? 2 plus 3 equals 5. 3 plus 5 is 8. 5 plus 8 is 13. You actually came up with that pretty quick. I'm kind of impressed. So, does anyone happen to know the name of that one? What it's called?
Fibonacci.
It's called the Fibonacci Sequence. Named after I'm assuming Italian, but he's called Fibonacci. Fibonacci. Now, my question for this is, could you find the 50th term? Could you? Yeah. Would it be a pain in the butt? Absolutely. Why? Because to find the 50th term, what else do I need to know? The 49th and the 48th. And in order to find the 49th, I need the 48th and the 47th. There's no way to nicely say, just plug in 50 into this formula, and you can get your answer. Right? So that's kind of where recursive rules come in. Recursive rules are different from explicit in that they rely on knowing terms before the one you're looking at. All right? So let me write what the formula would be for this Fibonacci one, just so you can see the notation. You ready? So it's always going to start f of x equals, or sometimes you'll see f of n. Now, you were saying that we added the term before. How do I say the term before this one? F of x minus 1. That right there means the term before this guy. Plus, what was I adding to it? The term 2 before it, right? So I added the term before and the term before that one. How would I say the term before this one? F of x minus 2. So this is the term before, and this one is the term 2 before. So that's my rule. To find any term, you take the term before it and add it to the term 2 before it. Kind of funky? Now, in order for a recursive rule to be complete, I can't just stop there. Because if I didn't have the sequence written there and I said, give me the first term of that sequence, how could you give me the first term of that sequence? You couldn't, could you? Even if I asked for the second term, you couldn't give it to me. Because it relies on previous terms, and it relies specifically on 2 previous terms, I have to give you 2 terms so that you can actually use my formula. So I'm going to give you the first term and the second term, And now you could come up with the third term, right? That's the first one you could actually calculate with this. You would say, okay, the third term is equal to the second term plus the first term. I have the second term and the first term, so I can come up with the third term. Does that make sense? Good answer. So my whole formula is actually this whole thing right there. It has to include those starting points. So whenever you see a rule that includes f of 1 at the end, or f of 1 and f of 2, that's your cue that it's recursive. Okay? It also helps that all of our recursive ones will have f of x minus 1. We won't see f of x minus 2 very often in there, but it'll at least have f of x minus 1. Okay? So, next one. Can you tell me what the next term is? This one's a little trickier. It's not Fibonacci. What was that? Multiplying what?
The previous number and the current.
Okay. Multiplying the previous number and the current what?
Number.
The current number. So in other words, if I wanted to find the next term, you're saying that I would multiply the previous term times what?
The current, the one you're trying to find.
Okay, so what number would that be?
240 times 48.
240 times 48? I don't know that that's it, because 12 times 48 I don't think is 240. 12 times 48 isn't 240. So what was the other suggestion over there? Times 6? Where are you getting 6 from?
Because you just keep multiplying by each term. If you want to find the second term, you do 2 times 2. If you want to find the third term, you do the second term times 3. And then if you want to find the fourth term, you do the third term.
So you're multiplying the previous term by the number of the term you're trying to find. So if I'm trying to find the 1, 2, 3, 4, 5, 6th term, I take the previous term and multiply it by 6. Let's see, 240 times 6. That would imply that this next one is 1440. So if I was looking to find the 240, say I didn't know that that term was 240, I would do what? I would take 48 and multiply it by what? 1, 2, 3, 4, 5. And that should be 240. Looks good. What if I was trying to find the 48? I would take 12 and multiply it by 1, 2, 3, 4. And it does give me 48. So I think we got it. Now we just got to figure out how to write that. Okay? So, f of x equals, what am I doing? I'm taking the term before. How do I write the term before in my formula? F of x minus 1. And what am I multiplying it by? By the term number, right? What's the term number? Not f of x. X. So that's my formula. But since it is recursive, I do have to include the first term. What is the first term? 2. Do I need to include the second term like I did up above? Why not? I'm only using the term before. I'm not using 2 terms before. If I'm using 2 terms before, I got to give you 2 starting numbers. If I'm only using 1 term before, I only need to give you 1 starting number. And that's my rule. Kinda so-so? Okay. Now let's get into some that are a little bit more reasonable. What do you notice about this guy? It's what? I heard an L word that I like hearing. Linear. Which we interpret as... This one's arithmetic. So if I asked you to write an explicit formula, you could, right? F of x equals 3 times I'm sorry, 3 plus 10 times x minus 1, and you would go from there, right? A recursive formula deals more with what are they adding each time? They're adding 10. Oops, not plus 0, plus 10. So how would I write a recursive formula? Well, I would say f of x is equal to, how do you find a term? You take the term before it, and you do what to that? You add 10. So I would say f of, how do I say the term before? X minus 1 plus 10. And what else do I have to include in my rule? The first term. Does that help me find the 50th term very easily? The 50th term? No, I would much rather use an explicit formula for that. But for most of us, our brain starts off thinking recursively. Our brain looks at this and says, oh, you're adding 10 each time. That's a recursive thought right there, not an explicit thought. Okay? So there's our arithmetic ones. So for arithmetic sequences, we have our explicit rule. Our recursive rule, by the way, they have n's, and I know that I've taught you x's, so just change those to x's and you're good. Our recursive formula would be f of x equals the previous term plus our common difference. There's no distributing for the recursive formula. You just write f of x minus 1 plus 10 if they're adding 10 each time. F of x minus 1 minus 3 if they're subtracting 3 each time. It's actually very simple to write those. You must include, however, f of 1 equals whatever it is. If you don't include that, you're missing part of the recursive rule. Questions about that one? I'm emphasizing that because this right here, this whole section right there is one of the most important parts of today's notes. The other important part is right here. So what kind of formula do I have over here? Or what kind of a sequence do I have over here? What do I have? Geometric. Okay. If it's geometric, what is my R value? This one I had a D value of 10. What's my R value here? How could I find that? 40 divided by 16? 5 halves. There's a glare on there, but that says 5 halves. Yeah? You okay with that? Now, just to verify, if I took 250 and divided by 100, whoops, I get 5 halves also. If I took 625 divided by 250, I get 5 halves. Because they didn't tell me it was geometric, I do like to check a few more fractions there. But there's my R value. So how would I write a recursive rule? I would say f of x equals, what are you doing each time? You are taking the previous term and doing what to it to get the next term? Multiplying it by 5 halves. So how would I write that as a formula? I have a term. If I'm trying to find a term, I take the term before. How do I write that? F of x minus 1. And I do what to that? Multiply it by 5 halves. Put a comma, because what else do I need to include? The first term, which is f of 1. And what does f of 1 equal? 16. That's my rule. So, our explicit rule for geometric sequences, again, you could change those n's to x's. That's our rule that we know. What would I say is my recursive rule? Well, to find any term, what do? You take the term before and you multiply it by r. No exponents, nothing like that. After that, you have to put a comma and you have to include the first term. So what's kind of interesting is these two statements are a summary of all the formulas that you need to know for arithmetic sequences. The only other thing you need to know is how to find the sum of an arithmetic series, right, with the summation notation thing. Geometric sequences, these are the two formulas you got to know. And then the only other thing is you got to know how to find the sum of a geometric series. FYI, I will be giving you formulas on the test, but I will not specify which formulas are geometric and which ones are arithmetic. Does that make sense? So if I gave you just a list of formulas, what do you notice about the arithmetic ones? They both have D, because only an arithmetic sequence has a common difference. The geometric ones both have R, because only a geometric one has a common ratio. So when I have a list of formulas that I'm giving you, you should be able to look at them and even label them right off the bat that says, oh, these two are geometric because they involve R, and these two are arithmetic because they involve D. All right? Okay, let's keep going. Use the given recursive rule to write the first 4 terms of each sequence. Then write an explicit rule for the sequence as we did in 12.1 and 12.2. Okay, so how do I know that this is a recursive rule that they're giving me? Couple reasons. Number one, they give me the first term, but also that right there. Remember, we should see x's when they have n's. That right there is saying something about the term before, right? So I need to find what? The first 4 terms. So let's see. I'm going to put my answer down here in this box. 1, 2, 3, 4. I like giving myself blanks to fill in. What goes in the first blank? 3. Because they gave me 3, didn't they? Now, if I want to find the second term, how am I going to do that? I take the f of 2 minus 1. Well, what's 2 minus 1? That means they're asking for the first term, and what am I going to add to it? 0.2. So what is 3 plus 0.2? 3.2. By the way, is this arithmetic or geometric? Arithmetic, how do you know? You're adding something each time. That makes it arithmetic. So what am I adding each time? 0.2. So I don't need to keep plugging in. I can just keep adding 0.2. So what would my next term be? 3.4 and then 3.6. There's my first 4 terms. Then it asks me to do what? Write an explicit rule for the sequence. So let's see. F of x, my explicit rule is the first term plus my d value. My d value is 0.2 times x minus 1. Now, some of you on your quiz, by the way, left your answer there. We have to keep going. 3 plus 0.2x minus 0.2. So f of x equals 0.2x, and then what's 3 minus 0.2? 3 minus 0.2, 2.8. And that's how I have to leave my explicit formula. My explicit formula, I don't need to say what f of 1 was, right? Only for the recursive. This is what I expected to see as your answer on yesterday's quiz. If you left it here, you lost a point because that's not simplified. Remember, you want to get down to that mx plus b form. Capiche? All right, let's look at this guy. Now this one, they are doing multiplication. What does that tell me about it? This one was arithmetic. This one is geometric. Now, Forgot to change that notation on the notes before we printed it. But that is f of 0. Now, sometimes, don't ask me why, because I don't have an answer about why. Sometimes they call the first term 0. It doesn't make sense to me. I think they should always call the first term 1. That makes sense to me. But just call term 0, consider it your first term. Okay? So if that's term 0, I have how many blanks? 1, 2, 3, 4. What goes in the first blank? 3. So what is this rule saying? To find the next term, or to find any term, you take, what does this mean? The term before, and what do you do with it? Multiply it by 0.2. So if my first term is 3, I am going to multiply it by 0.2. And that gives me 3/5. Since we're dealing in decimals, let's stick with decimals. I get 0.6. How would I get the next term? Take 0.6, which would be the term before it, and multiply it by 0.2. And that gives me 0.12. How do I find the next one? Times 0.2 again. Oops. And I get 0.024. Questions about that? All right, my last thing, I have to find the explicit rule. What's my explicit geometric rule? Well, it would be f of x is equal to what? The first term, which is 3, times what? Times my r value. What's my r value? 0.2 to the what power? X minus 1. And that's what my explicit rule should look like. Okay? So it is important that you know the difference between the explicit rule and the recursive rule. Okay? All right, here comes your homework. Happy studying.